This video deals with the concept of changing the subject of a formula. An equation is an example of a formula, and as you realize shortly, it's very important to change the subject of an equation, especially when you're solving linear equations. So consider this equation: x plus 1 equals 3. The equation states that x plus 1, this whole term, is equal to 3. But what if I wanted to know what x was? This equation is telling me that when I add 1 to the variable x, I get 3. But now I'm saying, what is x? What is x? And to determine what x is, you need to make x the subject of the formula. For your Y course, so senior secondary school course, you only ever be interested in making a variable the subject of a formula. But what is the subject of the formula? When a variable is the subject of a formula, it will only appear, conventionally, it will only appear on the left-hand side of that equation. And in the whole equation, you only find that variable on the left-hand side. Now, this second point, I'll make more obvious with a different example. But for this first point, let's use this example to demonstrate the first point. So a variable is the subject of a formula when it is the only term on the left-hand side. In this equation, we have two terms on the left-hand side. We have x, the variable x, and we have the number 1. We have two terms on the left-hand side. For x to be the subject of a formula, it has to be the only term on the left-hand side. Now, let me just show you what an equation with x as the subject of the formula is. In this equation, we have x is equal to 3 minus 1. X is the only term on the left-hand side, and x only appears on the left-hand side. You can't see x on the right-hand side. Therefore, here, x is the subject of the formula. In this equation, x equals 2. X is the only term on the left-hand side of the equation, and x only appears on the left-hand side. You cannot find x on the right-hand side. So in this equation, x is also the subject of the formula, the subject of the equation. In this equation, x is the subject of the equation. In this equation, x is the subject of the equation. So I'm using equation and formula interchangeably. In this equation, x isn't the subject. Why? Because there are two terms on the left-hand side. And for x to be the subject, it has to be the only term on the left-hand side. Now, the process of going from here to an equation of the form x equals ... anything is changing the subject of the formula to x, so that x is the subject, x is the main focus. So you can now say that x is equal to something. Anytime a variable is the subject of a formula, say you had the variable y in an equation and it was the subject of a formula, you're able to say that y is equal to whatever. So that's the concept. Now the next thing we're going to look at is the concept of preserving the equality of an equation. Now, as you know, an equation is a statement that says a term is equal to another term, or a bunch of terms equal to a term, or a bunch of terms. That's what an equation is. So what do I mean by preserving an equality? Well, okay, what I mean is that whatever is done to the left hand side of an equation must also be done to the right hand side of the same equation. So I'm using this as an analogy for an equation. Imagine we start with this bag of sweets. The number of sweets in this bag is 4. The number of sweets in this bag is 4 as well. So initially, the number of sweets are equal to each other. So we can consider this as an equation. 4 sweets equals 4 sweets. Now imagine that I take 2 sweets out of this bag. Imagine that 2 sweets are taken out of the right-hand side bag. We now have this scenario. There are 4 sweets on the left-hand side, and there are 2 sweets on the right-hand side. Are the number of sweets equal? No. Initially, we have equality. We change the right-hand side, and all of a sudden, we've lost equality. In order to preserve equality, whatever you do to the right-hand side, you must do to the left-hand side of an equation. So now, imagine if we take 2 sweets out of this bag on the right-hand side, and we take 2 sweets out of the bag on the left-hand side. We now have this scenario where the number of sweets is equal to the number of sweets on the right-hand side. Here, we alter the right-hand side, and we alter the left-hand side the same way, and we got this scenario. In this case, we only alter the right-hand side. So in this case, equality was preserved because what we did to the right-hand side, we also did to the left-hand side. And that's the underlying concept behind what we're going to next. Now, just to remind you, in a previous video I said we had an equation x plus 1 equals, I think it was 3. But in this case, x is not the subject of the formula because it's not the only term on the left hand side. Just to even start with that, there's another term on the right hand side. X will be the subject of the formula in an equation where you can say x equals something. So in this case, say x equals 2. In this equation, x is the subject. So how do you go from an equation in this form to an equation where you only have x on the left hand side? Well, it will mean that this plus 1 or this 1 on the right hand side will need to be removed. So we need to modify the left hand side. So when changing the subject formula, you'll find that you'll be modifying the sides of equations so that you can get the desired form variable equals ... equals something. But there are only some operations that are allowed on the left hand side. Now, you can multiply the left hand side by any number of variable. You can divide it by any number of variable. You can add any number of variable to the left hand side, and you can subtract any number of variable from the left hand side. And even others, for instance, you can take the square root of, and there are many more operations, but these are the key ones. These are the most common operations. So just take note, these are the main operations that we'll be using, and these are the ones you probably need in your Y course. But in general, anything you do to the left hand side, you can also do to the right hand side. But these are the main ones. We're doing multiplication, division, we're carrying out addition, subtraction, we're taking square roots and cube roots. So I'll give you an example. Again, the same equation we'll be using, x plus 1 equals 3. Say we want to make x the subject of the formula. Well, you want to get rid of this 1. We only want x on the left hand side. If you remember the rule, for a variable to be the subject of the formula, it has to be the only term on the left hand side. It can only appear on the left hand side. So let's get rid of this 1. How do we get rid of the 1? Well, let's subtract 1 from the left hand side. Let's subtract 1. So the left hand side, if you subtract 1, we have x plus 1 minus 1. That's the left hand side. So what about the right hand side? The right hand side is 3. Because we did something to the left hand side, we also have to do the same thing to the right hand side. So we also have to subtract 1 from the right hand side term in order to preserve the equality. So as you can see, our left hand side term here was x plus 1, and that's what's here. That's what's here, as you can see. That's what's here. Our right hand side term was 3, which is here. But we've subtracted 1 from the left hand side term, and we've done the same to the right hand side term to preserve the equality, which is why the equal sign stays here. Now simplifying this gives, well, if we drop the bracket here, we have x plus 1 minus 1 equals 3 minus 1. Now we can just simplify to give, what's 1 minus 1? Or plus 1 minus 1, that's 0. X plus 0, 3 minus 1, 2. So x is equal to 2. Now you can say that x is equal to 2. X is now the subject of the formula. X only appears on the left hand side, and x is the only term on the left hand side. So like I was saying, in the solution, x is equal to 2. X is the subject of the formula. We started with this equation, and now we've made x the subject of the formula. X is the only term on the left hand side. X only appears on the left hand side. There's an x on the left hand side. There's no x anywhere on the right hand side. In fact, on the right hand side, we only have 2. So that is the idea. Now we're going to move on to more examples that will involve using other operations, other mathematical operations, and we'll also try some more complicated examples. But this is the underlying concept. So here's an example. This one says make the highlighted variable the subject of the formula. So our formula here is this equation, and the highlighted variable is x. So the highlight in the case refers to the variable colored blue. Now, how do we proceed? Well, we want to go from here to an equation in the form x equals something. And we know that x should be the only variable on the left hand side, and x should only appear on the left hand side. Now, as it stands, on the left hand side, we have a minus 3 term and an x term. We do not want a minus 3 term, so we need to get rid of it. So I'm going to add 3 to the left hand side to get rid of minus 3, because minus 3 plus 3 is 0. 3 is the additive inverse of minus 3. That's another way to say it. Any term which you add to another term, it gives 0. Or rather, when the sum of two terms equals 0. They are the additive inverses of each other. So the additive inverse of minus 3 is 3, and the additive inverse of 3 is minus 3. So in this case, adding 3 to both sides allows us to get rid of the minus 3 on the right hand side. Simplifying this equation gives x plus 0 equals 3. So x is equal to 3. Therefore, we now have x as the only term on the left hand side, and x only appears on the left hand side. So x is the subject of the formula now in this expression. Here's another example. Same question, make the highlighted variable the subject of the formula, but this time the equation or the formula is different. Here the equation is 2x plus 4. As it stands, we have 2x and 4 on the left hand side, but we want to go to an equation of the form x equals something. So let's start by getting rid of the 4 on the left hand side, because we only want x on the left hand side, as you can see here. Okay, so to get rid of plus 4 or 4, you need to subtract 4 from this side, because subtracting 4 from plus 4 gives 0. 4 and minus 4, or plus 4 and minus 4 are the additive inverses of each other. But whatever we do to the left hand side, we have to do to the right hand side to preserve the equality of the equation, because after all, it is an equation and it must remain an equation. So subtracting 4 from both sides gives 2x plus 4 minus 4, then 0 minus 4. Simplifying gives 2x equals minus 4. As you can see here, 4 minus 4 gives 0. Cancels out. But we have 2x on the left hand side, but we only want x. We want an equation of this form, x equals something. So if you remember, one of the operations that you can carry out on the left hand side of an equation is division by a number. In this case, we want to divide through by 2 to get rid of the 2 so that we just have x. Dividing through by 2, let me do that here. 2 divided by 2 is 1. Dividing through by 2 gets rid of the 2. 2 and 2 is 1, and so now 1 times x is x, so we just have x on the left hand side now. 2 and 4, 2, so this is minus 2. So this simplifies to give x is equal to minus 2. Now x is the subject of the formula because it's the only term on the left hand side and it only appears on the left hand side. Here's another example. Make the highlighted variable the subject of the formula. In this case, the highlighted variable is p. It's highlighted in blue, the blue color. So we want to go from this equation to an equation of the form p equals something. To start with, as you can see, you have a 3p and you have minus 4 on the left hand side and you have 0 on the right hand side. To start with, let's get rid of the minus 4. Now you can do this by adding 4 to both sides, because minus 4 and 4 are the additive inverses of each other, which means their sum, minus 4 and 4, their sum is 0. So 3p minus 4 is the original left hand side. We're now adding 4 to the left hand side, and to the right hand side we're also adding 4. This preserves the equality. Simplifying gives 3p equals 4, but yet at this point we're still not in the form we want. We want p equals something. Dividing through by 3 gives us that final form, because we're just getting rid of the 3, and if you divide 3 by 3 you get 1. So dividing through by 3, which is kind of what we're doing here, 3 here, 1. This gives p equals 4 over 3. Just to make sure this division is clear, what was done here was 3 times p over 3, because that's what 3p is. 3p is 3 times p. So you can say 3 here 1, 3 here 1, which leaves you with 1 times p over 1, which is p over 1, which is p. And that's what we have here. So that's what this whole thing was about. P is 4 over 3 is the final form. Now p is subject of formula. P is the only term on the left hand side, and p only appears on the left hand side. Here is another example, a more complicated one from the ones we've seen. Here we have the equation f equals 2u plus v. We want to make u the subject of the formula. Use the highlighted variable in this case. So you want an equation where u is on the left hand side and the only term on the left hand side, an equation of the form u equals something. So a quick first step, a logical thing to do, is just to swap this left hand side term with this right hand side term. And doing so, this gives 2u plus v equals f. So what have we said? Initially, the equation we're given is f is equal to something. This something is equal to f. No rule has been broken. So now, in order to just have u on the left hand side, it will be a good idea to get rid of this v. And you can get rid of v by subtracting v from both sides, because v minus v is 0. Any number minus itself is 0. You have a number, you take away that number from itself, you get 0. That's the same concept. V is a variable representing any number, so it also behaves the same way. Subtracting V from the left hand side gives this, but the same thing has to be done to the right hand side to maintain the equality, to preserve the equality. So simplifying gives 2u, v minus v0 equals f minus v. Still not there yet. We want something of this form. Let's divide it through by 2, the coefficient of u, so that we can get rid of this 2 that's obstructing us from getting to this form. So dividing through by 2 gives 2u divided by 2 is equal to the f minus v term all divided by 2. Or you could say f divided by 2 minus v divided by 2, because we're dividing each term by 2. And now we simplify to give u equals f over 2 minus v over 2, which is the same thing as u equals f minus v over 2. From our video on subtracting a fraction from another fraction, when they have the same denominator, the resulting fraction has the same denominator, and the numerator of the result is just obtained by carrying out the operation you see with the numerator, so f minus v, which is what we have here. This is just a simple case of subtracting algebraic fractions. Here we just divided through by 2, because 2 into here is 1, f over 2 is f over 2, minus v over 2 is v over 2. That's what we have. In this case now, u is the subject of the formula. We have u equals f minus v divided by 2. U only appears on the left hand side, and u is the only term on the left hand side. Now here we have a much more complicated example when you compare it to the ones we've done. So I'm going to go at a slower pace. So in here we want to make the variable y the subject of the formula. You have the variable x, you have the variable y, but we want to make y the subject of the formula. We want to have an equation of the form y equals something. So a good first step is to swap the left hand side and right hand side terms. Why? Because now at least you have the term involving y on the left hand side term. On the left hand side. Here the term involving y is on the right hand side. So it makes sense to do that, because now we're getting closer, because like now y is now on the left hand side, even though we don't have the final form. So let's also get rid of this 1 over 4 term. So we just have the term involving y on the left hand side term. We do this by subtracting 1 over 4 from both sides. Remember, when you subtract a number from itself, you get 0. So 1 over 4 minus 1 over 4 will also be 0. So doing that here, subtracting 1 over 4 from the left hand side gives this, but you have to do the same thing to the right hand side to preserve the equality of the equation. Simplifying gives 1 over y squared. This goes to 0, so I'm just going to not even bother writing 0, which is 1 over x minus 1 over 4. Now, a good next step would be to simplify this right hand side term, and you see why shortly. Simplifying 1 over x minus 1 over 4, so just subtracting this, carrying out this operation is as follows. If you remember from the video on subtracting fractions, you can just multiply each fraction by the other's denominator to give an expression like this. When you want to subtract one fraction from the other and you have different denominators, take the first fraction and multiply its numerator and denominator by the denominator of the other fraction. So that's what I'm going to do here. And also to the other fraction, so you don't change the symbol or the operation. To the other fraction, multiply it through by the denominator of the other fraction. So in this case, 1 times x over 4 times x. And this gives 4 over 4x minus x over 4x. Here you see that now the two fractions have the same denominator, and you can easily simplify it to give 4 minus x over 4x, because you know when you subtract a fraction from another fraction, if they have the same denominator, the resulting fraction has the denominator of the original fraction being subtracted from each other, and the numerator is simply carried out by just writing what you see, really, 4 minus x. So that's really what it is. So simplifying this right hand side term gives 4 minus x over 4x. But we want an equation of the form y equals something. We're not there yet. Here we have 1 over y squared. So if you've come across the term of a reciprocal of a fraction, you know that the reciprocal of a fraction is simply obtained by swapping the positions of its numerator and denominator. In this case, you get b over a. So the reciprocal of a fraction a over b is b over a. In this case, we have the fraction 1 over y squared. The reciprocal is y squared over 1. But remember, to preserve the equality, whatever you do to the left hand side, you must do to the right hand side. So the reciprocal of this fraction as well is taken, and this gives this. We've just swapped the denominator with the numerator. Same thing we did here. We just swapped positions. So something like this, 1 goes to where y squared is, and y squared goes to where 1 is. Same thing here. 4 minus x goes here, and 4x goes here to the numerator. And that's what's been done here. Now, you can just tell that we're almost there, because y squared over 1 is same thing as y squared, which is 4x over 4 minus x. Why is y squared over 1 y squared? Well, if you recall from the videos on fractions, a number over 1 is equal to the number. 9 divided by 1 is 9. 8 divided by 1 is 8. Y squared divided by 1 is y squared. Now finally, to get an equation of the desired form, y equals something, we just have to get rid of this 2 here, because we have y raised to the power of 2. We have y squared. And how do you do that? You take the square root of both sides. The square root of a number squared is that number. The square root of 9 squared is equal to 9. The square root of 3 squared is equal to 3. And if you don't believe it, consider the square root of 3 squared. What's 3 squared? 9. What's the square root of 9? 3. What do we have here? 3. So the square root of y squared, we take so we can get y. But whatever you do to the left hand side, you have to do it to the right hand side. So the square root of the right hand side we also take to give this. Square root of y squared is y, as you can see from what I explained there, is equal to 4x or 4 minus x. So this is a complicated example, but as you can see, we now have an equation where y only appears on the left hand side and y is the only term on the left hand side. And the operations we carried out are as follows, just for a review. We started with this. We swapped the left hand side and right hand side just so we could have the y on the left hand side. We then got rid of the 1 over 4 so we could just have the term involving y on the left hand side. This gave us this. Then we simplified the right hand side term, which gave us 4 minus x all divided by 4x. Then we took the reciprocal of the left hand side so we could have y squared on top. Well, when we took the reciprocal of the left hand side and also the reciprocal of the right hand side, because whatever you do to the left hand side, you have to do to the right hand side. And then we had the expression y squared equals this term. And because we want an equation of this form, y equals something, we had to get rid of this 2, because we have here y raised to the power of 2, y squared. And the way to get y from this expression is to take the square root of this expression, which is what we did here. But because we did that to the left hand side, we must also do it to the right hand side. So we also took the square root of the right hand side term, and doing simplifying gave y equals the square root of this term. This term we can't really further simplify it, so you just leave the answer like this because it's in the form we want. Y equals something, and y is the only term on the left hand side and only appears on the left hand side.